another point of introduction here is let's look at some point z in the complex plane. As we start to think about it also too is that distance from the origin to that point, we talked about it as being the absolute value, but also in our polar context, that represents what we've been using the term as r in a polar coordinate form. And then we have theta as well. And that was a way that we can determine where a point exists. So what we're going to do is combine those two thoughts, polar coordinates and the complex plane. And how do we integrate those two ideas? So let me introduce to you a couple other points that we could use. So, let me start with my black one a little bit. So let's write the cosine of theta equals opposite or adjacent over hypotenuse. Solve that for a. So I multiply r by both sides. So I have r cosine theta equals a. Similarly, I'm going to look at the sine of theta, and that equaled opposite over hypotenuse, b over r. Solve that for b. I have r sine theta equals b. So if I look at this a, so I basically did is I solved for a and solved for b, and then in so doing, I can look back at my polar point, z equals a, which is r cosine theta, plus b, which is r sine theta, I. And then I'm just going to factor out the r just to clean it up a little bit. So it really equals r times cosine theta plus sine theta, I. And oops. I don't factor out the I of that last term. The I stays in there. I'm going to put it right there. So R quantity cosine theta plus I sine theta. And you can see that looks like R times A plus BI. So that's a mechanism or an equation that we can think about when we're dealing with polar coordinates in a complex plane. So let's say, for example, that we want to go ahead and write a particular complex number in polar form. And the example that we're going to look at is at the point z equals minus 2 minus 2i. All right, how do we want to do that? Well, first thing, let's plot. Not really sure where to start sometimes, but I always know if I can at least draw a picture, maybe that helps me have an idea of what to do. Remember to plot that. The real part is on the x-axis or on the real axis. The imaginary part's on the imaginary axis. And so I have some point right there in the third quadrant. To use my a, I have a equals a negative 2 and b equals a negative 2. I want to find these in terms of r and theta. Those are the two unknowns that I have. So I got to figure out is how can I go ahead and translate those and solve for r and cosine theta. Now, our book and a lot of other mathematicians call these particular, the value of r the modulus and the theta the argument. So sometimes you're going to see those terms of find the modulus or let's determine the argument of the particular equation. And so modulus refers to the r and the argument refers to the theta. All right, so we know what this distance is, and that's also r equals solve that on out. R equals a is 2 squared, 4 plus 4 square root. That equals the square root of 8, which equals 2 root 2. So find out the r. I know it's a 2 root 2. Now I want to discover what the theta is. And to do that, we'll remember that we have one other relationship in this complex polar form that we have, and that was the tangent of theta. Tangent of theta equals opposite over adjacent, b over a. So given that, I can also look at, I have a tangent of theta equals b over a minus 2 over minus 2 equals a 1. So what tangent, or what's the inverse tangent that equals 1? And you remember that that would equal pi fourths. I also need to remember that that occurs, the point I'm looking at occurs in the third quadrant. And so the tangent, or the theta equals pi fourths, that's in the first quadrant. We need to figure out what is its identity in the third quadrant. So basically I'm going to take this and add a pi to it. And that's 4 over 4, so I get 5 fourths pi. So the tangent of 5 fourths pi is 1, and its location also occurs in the third quadrant, which is where I know that my point z, negative 2 and negative 2i is also in that third quadrant. So I found my modulus, my r, I found my argument, 5 fourths pi, and now I'm going to reinsert those into my base equation that I have, and so I'll write it right here. So z equals, my r is 2 root 2, cosine 5 fourths pi, plus I sine 5 fourths pi. So there I go. I was able to transition or translate a point that's written in polar or in coordinate in complex. It's a complex number. And I was able to rewrite that point in polar form.